Go ahead.
Okay, I'll start over again. Welcome to the April 6th, 2020 session of Tangerine SDR and ASCII technical session. My name is Dave, KV0S.
That'd be 2021.
Oh, sorry, 2021, correct. My name is Dave, KV0S, and this week, I've been doing a few things, working on some magnetometer projects, building myself a Joules type container. So I did that, and I've been working on the programming and transferring of files back and forth. So making progress. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. Let's see, things are going fine here. I just finished up the Easter holiday and just moving along with everything. W2NF, back to net.
Fine business. Next on the list is Bill, AB4EJ. Go ahead, Bill.
Well, thanks, Dave. Progress this week has been kind of minimal. I've just come from the oral surgeon where I had a molar taken out in the back because it had a root canal on it before and it had been capped and it was falling apart. So I'm going to have to do the implant thing there. With regard to the project, I found out the TADD signal distribution thing from Tapper. It will distribute signals. However, it injects so much noise, as we thought might be the case, that it kind of obscures some of the Doppler information you want to look for. It's embedded in noise. So I put that aside. It can be used to distribute signal from the 10 megahertz GPSDO to multiple devices. Another thing that I had enjoyed this week was I got this in the mail. Don't know if you can read that.
Oh, look at that.
Oh, there you go.
Nice job.
It came in on Saturday.
That's great.
And I've already qualified an additional band on 30 meters. I just got to 100 countries with that yesterday. Next, I got to work on 24 megahertz. And then I'll have a 7-band DXCC. But anyway, that's about all. I might not be able to hang in there for a whole session tonight because I had to take some pain meds, and so we'll just see how things go. Back to net.
Well, fine business, and best of luck with that. I have a dentist appointment tomorrow, but it's only a cleaning. So next on the list, we have Dan in for XWE. Go ahead, Dan.
Thank you, Dave, and hello, everyone. Not much to report this week. Still kind of recovering from my surgery the week before last. So I'm hoping one more week and I'll be in good shape. Back to you, Dave.
Well, fine business. And next on the list is John in 8 OBJ. Go ahead, John.
Yeah, I made a new image for the Grape Gen 1 distro, but my script to take out all of the empty space did not work on it. So I want to get that there, and I want to push it up to whoever, I think it's Joe. Yeah, W7LUX. He's down there on the screen there. We want to push it up to his repo so he has it. Otherwise, I'm pushing up a 32 gig image, and his repo probably won't like that. So other than that, I've been working on Grape Gen 2. I'm planning on making, after I get my front end preamp eval done, I'm going to make a 4-channel preamp, and I'm just going to ship one to Nathaniel and one to Bill for a distribution amp, because they're supposed to be a low noise 7 gigahertz transistors. So I'll run the noise testing on it. And if it comes out good, I'm going to make a 4-channel of it and send a couple out for evaluation. Back to net.
Well, very good. Sounds like good progress. Next on the list, we have Bill in 8ET. Go ahead, Bill.
Not too much to report here this week. Had the grandkids up for Easter, and so I didn't get a whole lot done that day. And then the next day is recovery day, and we got absolutely nothing done on that day. About the only thing that's happened, I got my grate boards in from OSH Park, and they're down in the basement waiting for me to figure out what kind of parts to put on all those little tiny boards. That's about it for me.
Okay, well, sounds like you got your work cut out for you. Next on the list is Dave, KD0EAG. Go ahead, Dave.
Hello, I've got, I haven't done very much of great interest. I've worked on Fluxgate, magnetometer a little bit, and some other code this week, but otherwise nothing of great interest to anyone here. So that's pretty much my story.
Well, fine business. And next on the list is Dave, K0 or KO P4PAF. Sorry, I meddled your call sign. Go ahead, Dave.
Yeah, no problem. Well, I'm a newcomer. I just got my ham license last week, actually. I took elements 2 and 3, and so I've got general license now. One of the things that drew me to the hobby was research projects like this, and I just came across here, and I wanted to listen in a little bit. I've been doing some of the background reading and watching some of the previous, or listening to some of the previous sessions, these meetings. So hoping that I'll find some way to contribute, and glad to be here and listen to some of the great conversations.
Well, I'm curious, are you a engineer or a coder or?
Well, technically, no. I mean, I'm a hobbyist more than anything else. My background, educational background is network engineering, so it's not really engineering, but it's I did routers and switches and all of that kind of network configuration and that kind of thing. And I've done some coding and I've done I think Python, C, some other things like that. I've done some R statistical package a little bit and those kind of things. I've dabbled a little bit. I haven't really got a huge amount of experience in any one particular language.
Well, that sounds good. It sounds like you can look around and find a place to fit in. So there are jobs for skill sets that you have, and maybe you'll stretch to a new skill set.
Sounds good. One thing I am particularly interested in is FPGA programming. So, yeah.
Well, Scotty down later will be happy to hear that.
Right.
We always lacking FPGA programmers.
Yeah, even if there's grunt work to do, I'd be happy to try to come in and do what I can.
Okay, very good. Next on the list is David, N1HAC. Go ahead, David.
Good evening, everyone. Yeah, busy week, but let's see. Still integrating our VLF propagation rocket. Little hiccup on the vibe and nose cone deployment, things like that, but we're moving ahead and working on some VLF ground equipment, also some Antarctica projects, maybe go out on the ice, we'll see. And also puttering away on magnetometers. So
well,
a lot of things going on. Back to net.
I do have a question for you. Is this an up and back or a up to orbit kind of rocket?
Up and back. This is a sounding rocket. So it
okay.
Goes up, 10, 20 minute flight. But the idea is to get up above the ionosphere and see how VLF propagates through.
Very good. Thanks. Next on the list is Gary, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. This week I started working on some documentation for the Grape version 1. It's more of a background document and a little bit of a how-to. So when people come to HAMSCII and potentially inquire about building a grape version 1, that'll give them a little idea of what's involved in doing that. So I'm going to make some more progress on that this week. I think it's probably more appropriate. I'll discuss that maybe with John and Jim on a Thursday morning call. So back to net.
Well, fine business. And next on the list is James, KG4DSG. Go ahead, James.
Greetings all. Just checking in, listening. Came in a little late, but that's all right. And with that, back to the net.
Well, fine business. And next on the list is Jay, WB8SBI. Go ahead, Jay.
Hi, everybody. You guys aren't the only one dealing with health issues this week. Past week for me has been rather interesting, to say the least. I've got some health issues which are going to keep me occupied here for the next several weeks dealing with it. Other than that, yes, I'm still interested in getting the grape set, and I've responded to various people who have emailed me on the subject. I apologize for getting back to them so late. They emailed me over the weekend and last week, and I've just now been able to respond to them. So I apologize to everyone for the lateness of it getting back, and I understand tomorrow at 1300 Eastern time, there's going to be a Zoom meeting on the Grape One group. So I'm looking forward to participating in the correction Wednesday, not Tuesday, Wednesday. So other than that, hope everybody is doing well. 7-3, back to net, WB at SBI.
Thank you. And next on the list is Jim, K4BSE. Go ahead, Jim.
Good evening, group. Couldn't get the mute off. First, for AB4EJ, sympathize with you on the implant. I had one last year and it took a long time. I ran into some problems, so I feel for you, but finally got it and it's working fine. Well, let's see, several things this week. I'm kind of tired today. I spent the day over at the church. We had an event for our Pastor Emeritus there, and then had a streaming problem with audio yesterday I had to work on. Anyway, so I'm kind of tired this evening. Anyway, I do have the parts for the Grape One. They came in today. So I've got, I think, everything except the printed circuit board. And I don't know when I'm going to get that. I ordered it a week or so ago. And I got a note from them that said they had 366, I think it was, copies of that board on the panel they had just sent in. So looks like a number of people going to be building that thing. Yeah, we do have the meeting on Wednesday. It's kind of an organizational meeting for the people who are going to be helping with the the help desk, and figure out what we need to do to get organized. And I've had some correspondence with Nathaniel on that, and he's made some good contributions. I'm going to be trying to do a agenda for the meeting tomorrow and get that sent out, and hopefully in a reasonably timely manner. And let's see. Oh yeah, Gary, AF48 contacted me and told me about this document he was working on, and I think that's a very good idea. It fits in well with Nathaniel's note today. Important to make sure people in the group have accurate knowledge of what is going on. I wonder if we should have more refined documentation than John has up right now. He knows the material is there, but does it need to be rewritten? I don't know whether that's part of what Gary was thinking about doing or whether I'm off in the weeds again. But yeah, I think documentation is a key to this thing. And also, I want to make sure we define in the help group what we will and will not do to help people, because I'm worried about going down a rat hole of somebody who just totally screws it up and expects us to fix it for him. And how do we gracefully, without offending people, protect against that? But we'll talk about that on Wednesday. Back to Net. This is K4BSE.
Very good. And next on the list is Joe, K7LUX. Go ahead, Joe.
Okay, thanks, Dave. I've spent the weekend helping the girlfriend and all sorts of honeydew type projects, but I have been collecting data with the grape it's running, and I was collecting 5 megahertz data, and I switched over today to 10 megahertz, see what that looks like. I'm kind of puzzled by some of the results I got, which I posted on our grape website, but anyway, working on it, and probably able to help people get going if they have some difficulties. And the one thing that seems to be a little bit uncertain is that Nathaniel had to come out and flat say that you really do need a GPS DO to feed the heterodyning or the mixing signal into the grape. And there was at least one person who was wondering if there was a real cheap way to do this. So anyway, I've been working on all that. And if anybody wants any help or suggestions or comments on how my project's going, W7LUX@ARRL.net. Thanks, Dave.
Very good. And next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I don't really have much to report this week. I've been pretty busy trying to learn latex, and I'm using Overleaf as a learning tool, which is helping quite a bit. I'm still trying to figure out how to actually lay out a book, like how to, well, you know, the first couple pages of a book, there's the publisher information and all that. I'm trying to figure out how to do that. I don't believe you put that in the main.txt. I think you put that in a separate file, but I'm not sure. But I'm in the process of figuring all that out. Other than that, I don't have much to add. Back to the net.
Fine business, Jonathan. I feel for you. Finding a good template is usually the first step. I was working on a project about a year ago, working on some of Tom's book and pulling it together. It takes a while if you haven't used it before, but good luck. Next on the list is Jules, K2KGJ. Go ahead, Jules.
Good evening, everyone. And also congratulations to K0 or K04, I've messed up the call also, PAF on the general. Busy this week with a number of things, but not much on the HAMSCII front, except doping out the schematic of a flex gate that I purchased recently that Hyman and I are interested in checking out to compare with the units that Dave Witten has. With that, pass it back to Net.
Fine business. And on that note, I did get a email from Hillman, and he said that he had an urgent thing to take care of, but would continue working on things. So next on the list is Con, KE8QWB. Go ahead, Con.
Okay. Hello all. Yeah, I just left Arizona this morning. I'm currently about 100 miles away from Bakersfield. I'm going to see my daughters up in San Jose, spend a week with them. Then after that, hopefully I can find a secluded space, campsite, so I can do some stargazing and break out my SDR boards, and haven't been able to. Yeah, I can't wait. Hopefully, I can get something done. Back in that.
Fine business. Right in the middle, you broke up a little bit, but we got the beginning and the end just fine. Next on the list is John KJ6IBP. Go ahead, John.
Okay. Hi, everybody. I'm glad to be here and see all of you.
Well, thank you. So next on the list is Michael, AAK. Go ahead, Michael.
Well, thank you. Greetings to everyone listening. Back to you, Dave.
And thanks for recording these sessions, Mike.
No problem. My pleasure.
And next on the list, we have Scotty, WA2DFI. Go ahead, Scotty.
Well, good evening, everyone, and thanks,
Whoa,
Dave.
I'm not the only one with a haircut.
Yeah. What few hairs I have, I got cut. So starting to ask for a discount now because there's a lot less to cut up there. So anyway, I've sympathized with Bill. I had some dental problems this past week. He had a crown that was acting up that had to be replaced. So they took the top off and now the crown off and put a temporary on. And now they're saying that may have to do an implant there, and I really don't want to do an implant. So maybe Bill can fill me in on what an implant entails after the business is done. But because
I've got 3 of them.
Well, the dentist says, well, we could put a crown on, but if it's going to require a root canal, then we should just pull it and put an implant in. And I'm going like, no. Implant's the last resort when you can't do anything else with it. So, but anyway, I digress here. Not a lot done this week except cleaning up of the data engine schematic to match the changes that we made on the clock module so that they will both play together. Clock module is essentially done except for some cleanup that has to be done. And I've ordered the parts for a mock-up of the connectors on the data engine and clock module to make sure we'll have enough room between the connectors to actually physically use them. But I haven't got them. Apparently, not just for the COVID thing, apparently shipping is behind everywhere. So normally you put in a DigiKey order and you get it in 2 days. Well, I put in a Mauser order and it was like 3 days before they even filled it. And then it has to be shipped. So anyway, so I haven't got those parts yet. Also talking to John Ackerman about a test fixture for the clock module. Not really a test fixture for the clock module because that's the carrier board that he'll be working on later. This is a board that Rick Hambley laid out that actually takes the parts that we're going to use on the clock module and makes a big board, an easy board, like with 0805 parts and things all spread out, that we can actually test the performance of the actual chips we're going to use on the clock module. Because John only had different generation of synthesizer, and he had an older clock oscillator, and he had different jitter reducer. They're intended to do similar things, but they aren't the exact chips that we're going to use. So he can't really get any exact numbers. He can get approximations that they're going to help, but he can't get any exact numbers until we do this board. So Rick's laid it all out, corrected some things that John did, but Rick's now really busy with work and he doesn't have time to build them. So John is off getting some Chinese boards manufactured, some PCBs, and we're just going to take the boards over to my local CM over here and just have him assemble them. And it's interesting because all of the parts on the board I can place, except for one part has an underground pad. So, and I'm not really, I mean, I could probably fight with it and maybe make it work, but I don't have time to do that. So we're just going to take it over to the CM, and Tapper will pay them, $50 a board to assemble them. And then we'll have them in 3 days, we'll have the boards. So we'll send those off to John and Rick, and then we can expect John to come up with some real numbers of what our clock module is going to perform, how it's going to perform. So that'll be really useful. And I guess I think it's about it for here. So back over to you, Dave.
Well, fine business. Sounds like progress, even with dental work. And next on the list is Tom, GMT20210406. Go ahead, Tom.
Okay, busy week. Unfortunately, nothing on the project. And going in for a dental implant tomorrow. Oh. This is the month for everybody. Back to the net.
Say, Tom, I got a question for you.
Yes.
Have you made any progress on your updating of GNU radio modules for other protocols you were working on?
I've got a request out for 3.9. I haven't made any progress on that. I've got a pull request out for changing some system calls to be Mac OS compatible. Those didn't compile. I got new ones on those, but I haven't had the chance to try to compile them and test them.
I hadn't heard you talk about it for a while, so I thought it'd be worth an update.
Yeah, last 2 weeks have been frightfully busy.
Okay, thank you. So we're open for general discussion unless I missed somebody.
A question for Scotty. On John Ackerman's clock module, the GPS engine he chose, the mid-range one or middle-priced one, the reason he chose it is that the
I
one
want to welcome
GPS
everybody back for another case of the week here on Chairside Live. And I want to present this.
Oh,
case
Bill's got his
to
audio on.
practitioners again that want to incorporate implant dentistry into their practice. Obviously.
Okay.
Sorry.
I guess it's a real dental theme this week.
That's right.
And
Taking
John
a bite out of
Ackerman-
my time here.
Yeah, on John Ackerman's clock module, the thing that he liked about it is that the one PPS does not have the plus or minus 50 nanosecond sawtooth. It's corrected, so you could feed it straight into a PLL.
Okay, but that's on the Z part or some the more expensive part or the cheaper?
I thought it was the mid-range part had that.
Okay, and I'm not sure that the answer to that, but I know that the problem with the low end part was it didn't have a 1 PPS and a 10 megahertz output.
Right.
But I don't know about the, I mean, you have the part number, don't you? Of the mid-grade one?
I have it somewhere. Yeah, I just was trying to remember that's why he chose it or not.
Yeah.
Because if there is no sawtooth correction, you could feed it straight into a PLL and that's a piece of cake from Houston.
I seem to remember him saying that though.
Yeah, I thought that's what he said.
So what does a sawtooth correction actually do? Is it correct frequency?
No, on the low end GPSs, the 1 PPS, just before it comes out, it gives you a little string saying this one is going to be 17 nanoseconds short, or this one's going to be 3 nanoseconds past, because it jumps around depending on geometry.
It corrects jitter that would otherwise be on.
But this is a second to second jitter that they're correcting, right?
Yes, it's done in a serial string coming out, so you know what it's going to be, but you can't use it directly hardware-wise on a PLL because of that.
Because it's a string, right? That tells you.
Yeah, it's a string, and you can't move the edge of the one.
Oh, I see.
PPS.
Right. Okay.
Let's feed it into an FPGA, do your calculations, and then you're doing that on the fly all the time.
So then you'd actually have a circuit that would delay or advance the PPS edge.
Yeah, plus or minus 50 nanoseconds is the worst case.
Okay.
Which makes using it, like I said, directly with the PLL impossible.
Right. So since he is feeding the output directly into it's a trying to think how he does it, because he's got the clip sine wave that goes through a squarer and then gets fed into the synthesizer, and then the 10 megahertz goes in as a reference into the synthesizer chip, right? Though I don't know that he's using the 1 PPS in the synthesizer on board the clock generator on the CKM. I mean, I think the 1 PPS just comes off of the GPS, gets buffered and gets sent out. It doesn't go to the Silicon Labs part.
Yeah, it sounds like I probably need to sit down and have a chat with John, get that all straightened out.
Yeah, yes. Is that something that you have to have? I mean,
I need the 1 PPS, yes.
But you need the jitter-free 1 PPS, right?
Correct.
So how can you do that correction yourself on the Pi?
No. It's just going to affect when the sampling starts, but with an 8 kilohertz sample rate, plus or minus 50 nanoseconds, it's probably lost in the noise.
Because I can tell you right now that the 1 PPS is not corrected on the clock module. So you won't get a corrected one. Whatever the GPS provides, that's what you're going to get.
Okay.
Scotty,
So
do you have the part number for the
yeah, just
intermediate?
I will give it unto you.
And also for whoever was it Joe? No, it wasn't Joe. Somebody else who was writing a write-up on the Grape One. I put in chat room the link to all the documentation I have written thus far.
Yeah, I found that, John. Thank you.
Okay, Gary, there you go.
Yep.
I didn't see, I was looking for your face and I couldn't remember your call sign. Sorry.
Okay, let's see. So the fancy one is a Z-F9T, and the intermediate one is a Neo M8T. I believe that's the intermediate one. And the low end one is a Neo M9N.
That sounds familiar.
And the main difference is that, hold on a second, one of them doesn't have this. Yeah, okay, so the M8, yeah, the M8T and the F9N have an extra UART and external interrupts. So the low end one is the M9N, Neo-M9N. But did you want the intermediate one or did you want the low end one?
I think it's gonna have to be the intermediate one.
Yeah, because the low end one doesn't have a 1 PPS output at all, so that's not going to work for you.
That's not going to work for me.
So it's the Neo M8T. And I'm looking here at the schematic and T1, T2. Okay, the 1 PPS goes to an LED to show you whether it's working, an SMA for you to take it off the board. Both of those are buffered. Third buffered output is going to the connector to the data engine. So those are the 3 buffered outputs of the 1 PPS. And then we have the RF also has an LED on it to show that it's toggling, and it's buffered and it goes to the connector, the M.2 connector. So you'll be able to get both of those signals off the M.2 unless you, of course, you use the cheapy GPS, and then you'll get only the 10 megahertz reference. You won't get the 1 PPS.
Yeah, that won't work for me. So.
And I think it seems to me that on the cheap one, you could program the 10 megahertz output as a 1 PPS output, but then you don't get any 10 megahertz reference. So that's
you sort of lose.
Marginally useful. So you need both of those, right? What do you use the 10 meg reference for?
Well, think about this, because he's giving me the four frequencies, the 1 PPS, and then the 6th one I needed was the 8 kilohertz sample rate, but he couldn't go below 100 kilohertz, so I was going to divide it by 16 and ask for 128.
Yeah, so the problem with not having the 10 megahertz then would be that our synthesizer would not have anything to lock to give you your 4 frequencies.
Yeah.
Because we use that, we feed that into the Silicon Labs part as a reference.
Okay. Because you got a crystal oscillator on your board as well. What's that for?
That is to what we phase lock to, I presume. It's the
crystal feeds the synthesizer de-jitter chip. That's its reference.
But it also feeds the synthesizer too, Tom. It feeds through.
The 48 meg crystal is what the de-jitter chip references against to do its de-jittering.
But then it also feeds 48 meg out to the synthesizer too, right? It passes it through.
The synthesizer chip looks at the 48 meg ref to decide whether it's in lock or not, and uses it to de-jitter the signals.
So this is the schematic here. Can you see this?
Yep.
So the oscillator here, this is the de-jitter chip, and then this is the synthesizer here.
Ah.
So Tom, this
okay
de-jitterizes the output.
No. That chip sharpens up the edges.
Oh, okay. And then the de-jitterizing portion is inside the synthesizer?
Yes, that's correct.
Okay. So, but the point is, if we don't have this 10 megahertz here, this is the reference that we're using down here from the GPS is one of the reference inputs.
Mhm.
So if we don't have that, we're kind of SOL, right? I mean, we don't have any frequency control, any precise frequency control.
That would not be good.
So that wouldn't work. And then if you go back one sheet here, this is the these are the two GPSs, and they have a T1 and a T2. So the time pulse output here is the 10 megahertz, and the TP2 is the 1 PPS. This is the more expensive GPS. Then the cheaper GPSs have the same footprint, but you notice how they only have one output.
Mm-hmm.
So, and I think John said you could pick 10 megahertz or 1 PPS, but you can't get both on the cheap GPS. Now, the intermediate GPS, so I guess there is a TP2 connection here, but see, for the M8T only, I don't know if it's pretty hard to see this. I got it. So you've got TP time pulse up here for TP, time pulse 2 for TP2. So one of these is TP is 10 megahertz, TP2 is PPS, and then time pulse down here is 10 megahertz. And remember, only one of these is installed. So you're going to get the output of one or the other, but obviously not both. So then your TP2, which would normally be the 1 pulse per second, goes to this in parallel with this output. So if this is populated, the Neo M9N, this TP2 output is only a safe boot. It's not, there's no TP2 output at all. So no PPS. So then basically what will happen is these buffers down here will just be idle. They'll just be pulled up because there won't be any PPS output.
They'll be power consumers.
Power consumers, microscopic power consumers.
Yeah.
So I don't know if that helps you at all, but
is this schematic available yet, or have you released it?
Not yet, because it's not signed off yet, so to speak, because we may still be making changes depending on what we do with the DE, but it's getting pretty close.
Okay.
And I'm presuming I just put them up on the Tangerine site, right? I can send them to you, Dave, and you can put them up there, or?
Yes, we should be able to put them up there.
Okay.
Yeah, send me an email or something when you do that, because I definitely want to look at that.
Okay.
Okay.
Yeah, I'm looking at the M8T data sheet. I don't see anything about sawtooth correction. It shows plus minus 11 nanoseconds jitter.
Oh, okay, so it's just better.
But 11 nanoseconds is pretty good, isn't it?
It's pretty good, but it's
Weren't you
not
talking about more like
totally
50 to
corrected
100 for jitter? Hey,
I'm not sure.
Dave, does the F9T, the Z part, does it have sawtooth correction on the time pulse 2 output?
I have a similar GPS and it doesn't have any of that, what do you call it, sawtooth.
No correction.
So the thing you need to know about these chips is they have hundreds of outputs, but you can't get all of them at once. So if you read the data sheets on these parts, there's like 400 things you can output, but you can't output all 400 of them at the same time.
So you select which one you want on that.
Yes.
Right?
Yes.
Hmm.
I came across that when we were studying the TEC stuff, and the TEC stuff, most of the commercial boards don't put it out because most people don't care about it. But the boards still have the capability in the chip.
Yeah. The Z part says plus or minus 4 nanoseconds of jitter.
Ah, that's respectable. That's better than 10 times better than the other one. So, yeah.
So does that mean it's corrected, or does that just mean it's how it's more
They're
accurate?
using a different algorithm. They've obviously improved it.
Yeah, they've got the 2 parts. This one says 8 nanoseconds timing resolution, and the other one was like 21 nanoseconds timing resolution.
And that was the mid-grade one, right? That had the 20.
Correct. Yeah.
And like the cheapies you buy from Adafruit are 100 nanoseconds resolution.
So that's basically telling you what their internal clock is.
Oh, okay. That's 125 megahertz then.
Yeah.
Hmm. Yeah, and I don't think I have the data sheet here for the cheap guy.
Which was the cheap one again?
It was the M9N, I believe, was the number.
I
don't have that.
Yeah, Neo M9N.
okay. I bought one of those from Spark Fun, so
And they're inexpensive, right? Like $20, something like that.
the board is a little more than that, but they're very reasonable.
Yeah, I've got a Pi Hat board I made with the Adafruit one that takes a GPS and puts it into the system and reads the serial port on it, and then turns the Raspberry Pi into a Stratum 1 clock standard for the network for less than $30. So it's pretty cool.
So how does it actually do that?
Uses the GPS 1 PPS as its reference, and then it has that coming into the operating system, and they pipe everything. So instead of having a an oscillator that's running out, they use the 1 PPS for their timing reference.
Okay, but they still have the plus or minus timing resolution of whatever GPS they use.
But
So
they also
they
have
don't correct that.
Well, they have the data stream coming in. In theory, they could correct for it. Whether they do or not, I do not know. But I know I'm getting typically within 100 nanoseconds, or after you let the PID run for a couple of days, it really zeroes in on it. But that's sort of what I'm planning on doing with the Grape 2 for its time standard, is the same type of thing. That's why I needed access to the serial port to be able to talk to it.
Okay, and we give you that. We actually give you an I2C port and a serial port both, so you can pick whichever you want. Okay, I found the data sheet for the M9N. Let's see if it actually is going to tell me anything useful.
John, I use on my Raspberry Pi for my VLF SDR.
Mm-hmm.
What I do is I feed the pulse per second TTL level into one of the GPIO pins.
Yeah, exactly. Right.
Yeah, yeah, and I use the PPS GPIO driver, and I use that directly with GPS daemon.
Yep,
and so
that's exactly what I'm doing.
Oh, okay. All right, nice.
Okay, so it says accuracy of time pulse signal, 30 nanoseconds RMS. This is for the cheap one now. So you get,
so that'd be probably plus or minus 50. That sounds about right. Well, that's only 3.5 sigma.
So you can get and you can configure the output from 1/4 hertz to 10 megahertz. So I presume if you set it to 1 hertz, that's 1 PPS, and if it's 10 megahertz, then it's 10 megahertz.
Right.
It's interesting. It says accuracy RMS 30 nanoseconds, 99%, 60 nanoseconds.
They're playing games with the numbers.
So what that means is 99% of the time it'll be within 60, and then another 1% it'll be 2 seconds late. I mean, it doesn't say.
It's called a marketing breakthrough.
Yes.
Yeah, really.
Doesn't sound too Gaussian.
Yeah.
It's marketing statistics.
Yep.
That's right.
Make it look better than the competition, even though it's the same.
Like that. Remember the satellite dish antenna that was a pair of rabbit ears with a dish on it that looked like a, and they had all these things on there. You do not pay for cable because you're not getting cable. You do not pay for satellite because you're not getting satellite. Uses proven RF technology. Actually pulls signals right out of the air. And then at the bottom it says marketing breakthrough. And I go, yeah, it sure is.
Well, back in the 90s, I was writing a column for a cable TV magazine. And for the April issue one year, I put in a thing warning all the cable people that there was this new competitor for cable out there, and it used a medium called the ether for transmitting signals. And I took the power of a transmitter and converted it to DBMV that the cable operators use. So they launched this power, but then it's a passive network from there. And the set-top box is just a few pieces of wire on top of the TV. I got a email from a cable operator somewhere who wanted to hire me as a consultant to see if this thing had come to his town yet.
Did you get the job?
I couldn't figure out. I forwarded it to the editor and said, Gary, how do I answer this? And after thinking about it for a couple of days, I thanked him for catching and playing on with the joke.
Okay, here you go. I got it for you. The incredible ad. Let's see if I can share here. Only $5. And it's legal in all 50 states.
Oh my goodness.
Works like ordinary pair of rabbit ears. Well, yeah, because that's what it is. You pay no satellite fees because you don't use satellite signals. You pay no cable fees because you're not getting cable. I mean, this is a guy's a master of the obvious. Brings in every local VHF and UFO channel from 2 to 83. Well, misses out on one, sorry. Uses RF technology to capture signals right out of the air.
Wow, you can do that?
Yes. I think you can get 2 for $10 if you're really a sucker.
Where is
for
this?
$20?
Oh, this was an ad from like there's a date down here. I can't even read it, but it's like from the 1980s. You know, it's
Oh, yeah, it says here just above it, August 12th, 1990.
yeah, there you go. Oh, click for larger version. Well, I don't know if that
From
Great Magazine's Hall of Shame.
yes.
In the early days of satellite distribution and cable TV, we were at a trade show one time, and there was this guy showing this satellite dish that was made with 1x2s and chicken wire for the reflector. And my colleague at the time, Alex, was talking to him. He said, "What are you trying to do here? What are you doing with that thing?" And he said, "Listen, fella, I'm doing the same thing you are. There are people out there walking around with money in their pockets. And I aim to transfer some of it to mine."
That's right. That's
Well, at least he was honest about it.
Yeah, it's a marketing breakthrough. You know, cash your mind. But I like this. If you look down in here, it says compatible with all TVs from 3-inch portables to giant 7-footers. Sits on any TV top in less than 4 linear inches of space. Now, doesn't this really sound at all technical? Guaranteed not to utilize, replicate, transmit, or interfere with any satellite signal. That's a great one. Guaranteed not to make malts like your blender.
I want to get the Jacob's ladder option.
The which?
The Jacob's ladder option.
Yeah. I just love this. Actually pull signals right out of the air. Oh my.
Is anyone into time travel? I've got one for you if I could share.
Okay, let me stop and
let's see, where did it go?
So I figure time travel hasn't been invented yet because, like on Big Bang Theory, they said the first thing that you all promised to do if you invent a time travel machine is to come back in time to this instant right now and tell me that you did it. So since nobody appeared, obviously nobody has invented the time travel machine yet.
Remember
Oh, there it
Hawking's
is.
invitation to the time travelers?
Yeah.
There you go.
Oh, the flux
Oh,
capacitor.
yeah. How much does it cost?
It's not available for purchase.
Oh, man. Had to take
They
the
must
fun
have
out.
sold out.
I like the
Yeah.
plutonium compatibility. That's
Yep. Just needs a little plutonium.
yeah,
that's
plutonium
easy.
is required. Talk to the Libyan terrorists, you might get some.
Yep.
But they got the maximum power off. It's 1.21 gigawatts.
Yeah, yeah.
Well, in the text below it says 1.21.
Mm-hmm.
But yeah, you're right.
But you do need a DeLorean.
Damn, my VW bus won't go 88, so I'm out. If you drive it off a cliff, it might get up to 88.
Looks like they also misspelled gigawatts.
Yes, they
They
did.
showed gigawatts. Gigawatts is with a J, isn't it?
Yeah.
No,
No,
it's just a mispronunciation.
This is the correct pronunciation. Yeah, I mean correct spelling. I had a
I say
professor.
gigawatt.
I had a professor that used to call it gigawatt, and we used to laugh at him.
Yeah, I think it might be a secondary pronunciation, but we call it gigawatts.
Yeah.
Anyway, we'll have to keep bothering O'Reilly Auto to
Yeah.
Yeah.
get it back in stock.
Well, yeah, I played for you guys the Kitty's explanation of the cloud. You need to go Google that and watch it. She's an Australian comedian, and she gets on this show with the host, and she's going to explain the cloud to everyone in layman's terms, and it's hysterical. It's definitely not appropriate for to record on here, but go find it yourself and watch it.
What's the name of it?
It's if you search for Kitty Explains the Cloud. I don't know what Kitty, that's her name, and she's an expert. Okay, and she comes on the show and she's going to explain to you what the cloud is. And she says, "Well, I learned what this cloud was. Basically, I went to Wikipedia and I read about it." And so the host says, "Well, what did Wikipedia say?" And then she gives this super technical, incomprehensible definition, and he interrupts her and he says, "So wait, what does that mean?" And she says, "Well, it means that Wikipedia doesn't know what it is either." And then she goes on to explain it with the example, and it's just a riot. You got to go look at it because it's.
Well, that's like the T-shirt that says "Danger, 100,000 ohms."
Yeah, danger, high resistance. Okay, now all you guys that were hams more than 40 years ago, when you got your license, you probably got a packet from the little print shop, right? Anybody know what that is?
Oh, yes.
So, and in there was a couple of cards, and one of them was danger, high resistance. And it was a QSL card size with red lettering on it. And you're supposed to stick it on your transmitter and just really impress people that it had high resistance. And in fact, I got a mailing from the little print shop with my call sign in it before I got the FCC license.
I didn't.
So I knew my call sign before I actually got the license. So
I think I got one time too. You put on, it said danger 1,000 millivolts.
Did you get the one that said equipment not to be operated by amateurs or something like that?
I don't remember that one.
there were a couple of placards that you got in there. They wanted you to buy QSL cards from them, is what they were selling. And I actually bought some from them because they were cheap, and I was a high school student, so I needed cheap.
Well, I remember the billboard that Dayton, this would be in the early 80s. It was Larson's Antenna, and they had two billboards, full-size billboards on the way to Hera. And one of them said, it takes amateur to be a pro. And the other one was amateur radio is no place for amateurs. That was Larson's antenna, and I still have Larson's. They got bought out, but they're good stuff.
That billboard's had to cost them $5,000 to get the full size one like that.
Yeah, I mean, by the road. Yeah, it was wasn't on I-75. It was on one of the side streets, but it was a full size billboard on the way to Hera.
Hams have arrived, and we can afford billboards.
Well, this was the early '80s, late '70s, early '80s.
Yeah. All I ever saw at Dayton was guys with hard hats and Yankees mounted on them walking around.
Yeah.
Nathaniel, if it is necessary or if you would like me to attend any of these grape coordination meetings, let me know.
It's probably a good idea, especially for at least the first one or two. Maybe to just get them off
send me
the
an
ground.
invite to them then, because I don't have any information on that.
Yeah, I thought they sent it out to the whole group.
Or maybe I just didn't see it.
Yeah, maybe. Yeah, I saw mine, was it yesterday or today, and I responded. So it's Wednesday at 1300 Eastern time on Zoom. And there was
because I saw there's something on our calendar, or my calendar, 8 o'clock. There was an NJIT great meeting. Did I miss that?
A what?
For NJIT?
What day was that? Today? You mean?
That was with Gareth. I missed it. Oh, geez. Oh.
Must be the dental work.
Yeah.
But yeah, I think that would be really helpful, John. I won't be able to make this one, but I think once they get started, they'll be okay. But they'll probably need a little advice, especially at the beginning. And I guess you saw there were a lot of questions, and I know Jim was talking about it earlier about exactly. I think there's some misunderstandings as to what the need is for the GPSDO and kind of what your scripts do and things like that. I tried to answer a bunch of those questions on the list.
Yeah, I was gonna throw together an error budget showing a standard crystal, and the variation just with a 1 degree temperature change is the entire measurement we're trying to make.
Yeah. So, and I think, I went to Christina, Steve Serwin, Dev, and I were working on this other paper looking at the Doppler shifts during the eclipse and during some of the festival frequency measurements. And Steve Serwin's been doing these really nice measurements of the Doppler shift and really tying it back nicely to what the ionosphere is doing. And I asked him, what he thought the hard numbers were for like a minimum requirement for GPS DO, and he didn't have hard numbers either. So he gave a little bit better response than that, but
I'm shooting for a 1 millihertz resolution.
Yeah, I think that's reasonable.
I think anything above 10, you're wasting your time.
Yeah, I think that's reasonable.
Yeah.
Well, how many people do you think are going to build Grape Ones?
You want an honest answer from me?
Well, what did the guy make? 300 boards?
300 boards?
I
thought they were being ordered from OSH Park 3 at a time.
Well, they usually tell you how many are on each panel when it gets panelized.
Yeah.
But that doesn't necessarily mean it was 300 of my board.
Of your boards. Okay.
On the 18-inch square panel.
Oh,
that's what they do. They just keep accepting these and put them on a panel. When they fill it up, they send it out.
Oh, okay.
So
it's not 300 of your boards. Okay.
I know several people that have already gotten boards, so.
Should be $6.60 with shipping, free shipping, which is US mail. And they have a standard 10 business day turn. If you get their Swift one, it's a 5 business day turn. And for example, the board I turned in with the preamp tests, they upgraded it to the Super Swift so they could fill the panel. And probably about 40% of my orders, I get that. So you don't have to pay for it, but you get it in 5 days instead of 10 days. So it's kind of nice.
Yeah, mine came something under than 2 weeks.
Yeah. They do good. They do a really nice job. Their silk screen is great.
Yeah.
And a little secret,
They're real good. They're real good about letting you know how the progress is going on the boards.
Yeah, yeah. And the alliteration for their name on the website, guess who that came from?
You?
Yep.
So Nathaniel, what are you hoping for 100th of a hertz, or I think 1,000th is kind of wishful thinking. That's the limit of a Leo Bodnar GPS is better than a 1,000th. I mean,
Yeah,
it's
I
more
think
than 1,000th.
100th of a hertz is a millihertz. That's what John was saying. Yeah, that would be great.
Well, that's 10 to the 9th.
Yeah.
Yeah, we're shooting for, at worst case, a 10 millihertz resolution. I'm shooting for a 1 millihertz resolution.
Have you looked at the graph I posted? Boy, that thing's all over the place during the nighttime on 5 megahertz.
That's normal. If that's depending on how, I'd have to take a look at it because some of my plots, I could probably put them up there.
I've got to go turn a radio down. Racy's net.
Yeah, I'm going to have to skedaddle there pretty quick anyway. So
I'm going to say 73. And
yeah, Nathan, if you could send me that link for Wednesday.
Sure.
Try and make
I
that.
can do that.
And I need to go apologize to Gareth.
Yeah, I see the Joe, I see the plot that you showed here. In here, I can just put it on the screen really fast. So yeah, so this is all the variability you're talking about here.
Yes, I just got back from turning a radio down a little bit.
Oh yeah. So this is the figure you showed. This is all the variability that you talked about.
That's what I'm kind of concerned about. If you look over to the right at the morning, I guess that's the morning sunrise.
Yep.
Yeah.
And
So this is the morning sunrise. Yes. And then so this variability that we see here, this is typically, I believe it's probably because of this mode splitting. And so if you look at this is where we're going to be moving away from this form of collecting the data where we're just doing one data point per time. And we're going to move to more of a full spectrum sort of solution. And if you look at Steve Serwin's Tapper presentation and paper, he shows this really nicely. Yeah, so like right here is an example where on the top here, this is taken from FLDigi, and you can see all this variability going on here. But if you actually put it into Spectrum Lab and you were able to get more than one frequency reading per unit time, so you're actually showing a spectrum, you'd see that the spectrum of the received carrier splits up into 3 or more. And so the FLDigi frequency estimation algorithm is just trying to pick out one of these. And so it's just jumping up between all of them, and you're getting all of that variability.
Yeah, it just grabs the largest signal.
Right. So what's going to happen is in the next, Bill Engelke has already come up with a new firmware image for the grape that will save this full spectrum information rather than just these single points, but it hasn't been fully packaged up and distributed yet.
Well, there is a distributable image that's on the shared website.
So then yes, you can get that new image that will give you these different plots, but it's a very new thing for us.
Yeah, and you need to make sure you allocate plenty of storage space because it saves the data using digital RF. I suppose you could turn that off and just watch the GNU radio waterfall output. So.
More to come.
Guys, I have to get out of here too. I'm running down, so.
Yeah.
73.
7-3s, take care.
We'll be in
73.
touch.
73, everybody.
7-3.
See you folks. See you next week.
Thank you so much.